scales. There will be the conversions between all the temperatures on here, but you do want to remember that there's Fahrenheit we use, but we don't use that in class. We use Celsius or Kelvin. And Kelvin, 0 is where everything stops moving. And so at 0 degrees Kelvin, we call it absolute 0. That's why we wanted to use the scale of Kelvin. So water freezes at 273 degrees Kelvin and 0 degrees Celsius. So that's where we get the relationship that degrees Kelvin is Celsius minus 273. Okay, and so these are the 3 scales, and we're going to be using these a ton in January, so be ready for that. Okay, significant figures and calculations. Remember, we need to multiply and divide. We're going to be using the least significant figures. So we have 5 sig figs here, only 2 sig figs here, which means we can only keep 2 because we're limited by the least sig figs. Okay, so we want to round it. Now, a lot of you on the test would just take all the numbers off instead of rounding it to the nearest. Is this closer to 26,000, 27,000, or 26?
26,000.
26,000. You can't forget those placeholder zeros, right? If I said here's $26 or $26,000, is that a big difference?
Yeah.
Yes. Okay, so remember that at the end when you're rounding. Remember when you add or subtract, when you add, look at the dad, the digits after the decimal. So here we have 4 dads and here we have 1 dad, which means that our answer has to be to 1 digit after the decimal. Don't expect all the questions to try to trick you and give you multiple possible answers, but there will be some questions that are specific. Multiply these and give us the right answer. When it asks you something like that, look for the sig figs. That's intentional. Okay? When we look at significant figures like the song, the leading zeros are never significant. Whether or not there's a decimal, it doesn't matter. They're never significant. And when I say leading zeros, it's before the first time we have a non-zero number. Okay, so this 3 says, oh, before that is never. The middle is always significant, captive zeros. And the end is sometimes. That's when we do the yes dot, no dot, no. If there's a decimal somewhere in the number, they are significant. If there's no decimal, they're not significant. We will see the scientific method on the test, I guarantee it. So we have observation. What do I see? Oh, now I'm going to hypothesize about what I see, and then I have to experiment, collect data, and from there I can either get a scientific law like the law of gravity, or I can get a theory. For instance, the Bohr model was a theory, right? Because do we still believe in the Bohr model? No, we have Schrodinger's model with the electron clouds. It's a more accurate representation. But at the time, all of the evidence that we had, this was a way to explain it. We have new evidence now, which needed a newer explanation. And so that's how we have our current theory. But there's no way at this point to actually look at an atom at that level. Until we have some kind of technology that can actually see an atom, we have to go ahead and go with it as a theory. All right, precision and accuracy. You are at Buzz Lightyear, and you are trying to shoot the target. And every time you shoot, you hit upper right-hand corner of the target. Do you get the points? No. You are a precision shooter. Every time you shoot, it shoots the same place. But if it is not an accurate shooter, it's not going to be successful. So you want to be both precise and accurate. But sometimes we can have reproducible results that are not accurate. And we have to remember that when we're doing labs and experiments, that sometimes our results might always be the same, but they might not be the right thing, depending on how much error is in the lab. All right. Ooh, conversions. Remember, if we have 2-unit conversions, what you want to see is if you're starting with something like kilometers per hour and moving to meters per minute, you want to identify your conversion factors. Oh, I need to change kilometers into minutes. Or kilometers into minutes. Kilometers into meters. 1,000 meters is a kilometer. Hours into minutes. 1 hour is 60 minutes. Now I have my conversion factors. For each conversion factor, I'm going to need a fraction, and you're going to set it up so that the old units cancel, and you have your new units. All right, don't forget, multiply by the things on top, divide by the numbers on the bottom. King Henry died by drinking chocolate milk, right? Kilo, hecta, deca. Base unit. What's the base units?
Meter. Grams.
Meters, liters, and grams. Also other things like bytes, gigabytes, terabytes. Those are all base units that we can apply this to. Okay. Deci, centi, milli. Once we move out and get to a micro, nano, and pico, remember it's 3 moves of the decimal. Okay. And all you have to do is start your pencil in one place and move it, and then put it on the decimal and move it that many times. And I think that's everything that I have for the first 2 units that we did this semester.